For this second part of the video, I probably won't do as much background explaining on how things come to be. I mostly just want to try and get through a couple examples in one video. So let's get started. Car traveling at 15 meters per second off the edge of a cliff. Looks something like this. We've got our cliff, car driving perfectly horizontal, so 15 meters per second horizontally. Cliff is 55 meters. And it's going to eventually land somewhere in the water. We want to know how far. So in order to do this, we set up those same two equations. In the x direction, the components that make up the x position of this object is our initial velocity, 15 times t. And in the y direction, we get our initial height, 55. And there is no vertical component to the velocity here. So we just skip that. But the other component that factors into y is our gravity. And we're metric, so we're minus 4.9 t squared. Again, if we're trying to find how far from the base, we just say, well, if we know that at height 0, a certain amount of time has passed for the object to have free fallen, then we can figure out how much time has passed. And if we know how much time has passed in the vertical, we can apply that to the horizontal and find our answer of how far from the base. So let's see. 1122. So we take the square root of that, and the answer is 3.35 seconds. That is how long the object was in free fall vertically. And then we say, well, if it was traveling for almost 3.5 seconds vertically, we also know that it was traveling horizontally for about 3.5 seconds. So x is 15 times t on that. So if we plugged in the 3.35 in the horizontal, we get 50.25 meters from the base of the cliff. Always double check that that's the only question that was asked. How far from the base does it strike the water? And we are good to go. So that is it's very similar to example 1, which there's a whole video where I do a little more explaining in the background. Example 3, we go a little bit backwards here. And by backwards, I mean we're solving for a different variable. Rather than knowing the vertical, finding it, plugging it into the horizontal, we kind of go backwards and use the horizontal to find the vertical. So here we have a building, and we know the object comes out of some window. We don't know how high up from the ground in the building this is, so we don't know this height, but we do know that it is 30 meters to here. So we know that it took 30 meters to get to that's how far it landed away from the building. So the question is, at 16 meters per second horizontally, landing 30 meters away, how far up the building did this ball come out a window? So let's do this. We say x is equal to 16t. We're going to set up our equations just like we did before, but here we have our h sub 0 as an unknown. So we don't know what it is, but we still have to account for it. Here we have three unknowns, y, h0, and t. That's way too many unknowns for one equation. But let's look at this. Rather than plugging in, well, when y is 0, finding t, we still have two unknowns. But look at this. Let's look at the horizontal. Can we not say that, you know, at 30, it traveled 30 meters, our ending horizontal distance x is actually 16. Oh, I'm sorry, not 16, geez. Is 30. We know that the ball eventually traveled a horizontal distance of 30. And that was because at a velocity of 16 meters per second, some amount of time passed and we ended at 30 meters. So we should be able to use the x equation to find t. And get the exact here. So after 1 7/8 seconds, we've landed at 30 meters. Now, excuse me. Now we can say, well, if we know t, we can plug it into this equation, and we can still use y equals 0 and say, well, after some amount of time, rather than knowing the starting point and setting the end and finding t, we're going to use the fact that we still hit the ground, so our final position is still 0. We want to say our h naught minus 4.9 t squared, but now we know t. This is going to allow us to find our h naught. So let's plug this in. And we get 0 equals h0 minus 1722. Therefore, the h sub 0 is 1722. And how high above the ground? I would say the window is 17.22 meters. Let's just say above the ground. There you go. Let's see. So yeah, double checking we answered any questions. Sometimes the question, the problem will actually ask for how much time is the ball or the object moving. So, but in this case, it does just ask for how high is the window. So I'm going to stop this video here because the next couple examples use an angular projectile. So it's a little bit different. Same process, we don't get to simplify things as quickly. So I'll stop this one here, and part 3 will be projectiles that are actually launched rather than horizontally. We may have it launched at, say, a 40-degree angle. So yeah, that's it.